Next slide. Now what about Rhode Island? Adult cancer is the second leading cause of death in Rhode Island. And if you look at childhood cancer, I was horrified when I saw these numbers. It's 1 in 300 boys and 1 in 330 girls will develop cancer before the age of 20. It causes 12% of the deaths for those between 1 and 14 years of age. And from some early data that had between 92 and 2004, the rate was increasing by 0.4% per year. Childhood cancer, for the most part, is triggered in utero. That means the children were exposed when they were a fetus, and they're born with the cancer. Now, what can we do? Next slide. Now, what are the options for the future? We need to improve our prevention. And a big way is replacement drugs. This is my specialty. I was involved in Campath, which is a drug that gets the immune system to attack the cancer. I'm also involved in the development of a cancer vaccine. There are Herceptin, which many people have heard of. It's used for breast cancer, and what it does is it slows the growth. Velicade is an amazing drug. It used to be second line with myeloma after cyclophosphamide, but because it's so good in the last couple of years, it's now used as first line. Unfortunately, the ADC, the Herceptis, came out in November. It's a replacement for bleomycin. And this is best described as a Trojan horse. And there's an antibody that has incredible toxin, but the toxin is not active until the antibody gets to the cancer cell, and the cancer cell pulls it in and gets blown up from the inside. These cells are great because they attack cancer cells. They don't attack normal cells. Problem with, it's going to be 15 to 20 years before we have replacements. We need to retire cyclophosphamide, but we have nothing else. It's kind of equivalent to where we used to use mercury to treat syphilis until we got antibiotics. Now you would never consider using mercury for syphilis. So we now have to think of what are we going to do until the replacements are available. You know, these materials are coming out as active drugs in the patient's waste. Should we be doing something about it? Or do we have to start looking at the alternative, which is to prepare for more pediatric cancer? On that lovely note.
Thank you for the good news.
I'm sorry. Things are moving in the right direction. It has been an absolute revolution in just my working career in drug development of the things that we're coming up with. But we're not there yet, and it's a slow process. I think we now estimate it takes $1.5 billion and 15 to 20 years to develop a new drug. It's coming, but it's going to be a while. And what do we do to prevent the cancers that are being caused by the treatments we use now?
Any questions of Theresa? Mark?
Yes. Is there any state or federal agency that has a drinking water standard for cyclophosphamide?
Europe is looking to develop, but in the US, they're not even testing the water for it. They're not testing the ponds. They're not testing the ponds on Cape Cod, which I think would be a very smart first step. But there is, for some reason, there's not even giving grants out to academic units to do studies.
Idea of how many patients are on cyclophosphamide at any one time in the state of Rhode Island, say, or now?
I'm sorry, I have no idea. It's a very commonly used drug, but they are trying to move away from it because it causes, within the patient it causes bladder cancer, it causes bone marrow failure. There's a woman that does a Good Morning America that a few years ago, she was treated with cyclophosphamide for breast cancer, and now she's having to get a bone marrow transplant from her sister. It's a problem. They really would like to get away from it, but we don't have replacements. It is a very good drug for the patient. It's just not good for anybody else.
In the last meeting, I heard testimony that the percentage of pharmaceutical ingredients that is excreted is somewhere between 1% and 2%.
Well, actually, they said excreted. I was looking at it because I was curious about that. Like excreted and metabolized. It was how you you get how the drug is disposed of. They were saying 1 to 2% gets flushed, and the 98% is excreted and metabolized. There's a thalidomide. I'm not sure how many of you know the thalidomide story. It was not allowed in the US, but it was allowed in Europe. And the kids were born without arms and legs. Thalidomide is actually it is being used very successfully here in the US for brain cancers. Thalidomide, with all its horrible effects for the patient, and if it's into the environment unused, is completely destroyed by the body. So anybody who takes a pill, it is handed as a rectal waste and has been since 1990. That was Marjorie Powell had given a description of the very careful handling of the unused. But once it goes into the patient, it is gone. We never have to worry about it again. It's specific to the drug. Mustagen, which is the forerunner of cyclophosphamide, is completely destroyed by the body. Cyclophosphamide is not. There is a derivative of cyclophosphamide. It begins with an L, and I have it on the list, but I can't remember its exact pronunciation. Lianmalithide or whatever. Something like 60% of that comes out active. So you have to look at each individual drug. Either the drug insert, which a lot of these ones that are hazardous actually do list how much comes out active, or with the published studies that were used to actually get the drugs approved. They do have the information there. I'm a scientist, this is my background. I know how to create the ADME studies, I know how to run the PKPDs. It's not my specialty, I tend to make the drugs. Yes, I understand it. I can understand a layperson would not be able to, those drug inserts you're supposed to be able to understand, but most people can't. It can be hard to understand what the information is. But the FDA does have the information of how much comes out active, how much comes out as metabolites, how much comes out as dangerous metabolites or non-dangerous, and how it comes out. It is there. It does exist. This is why the NIOSH list has 167, because they are so dangerous that they require employers to provide their employees with very strict guidelines on how to handle everything, including how to handle the bed sheets from these patients, because the material is so dangerous and we know so much comes out active.
Any other questions? I have a question for the committee. Obviously, we don't have this on paper. Would you guys like this emailed to you tomorrow? Could we do that, Caitlin, please?
I'm very willing to do it, and I've given my contact information. Please email me.
We'll get it to the committee tomorrow. Thank you very much.